Hi, I'm Eric from Alpha Power Solutions, and today we're talking about electrical harmonic distortion and what factory managers need to know. So they will typically experience premature failure of electrical and electronic equipment. They will notice that some of their electrical cables are overheating even though they're correctly rated. They'll notice that the site has a very poor power factor, that their transformers are overheating, and that they're experiencing tripping of circuit breakers and fuses blowing for no apparent reason. So what I'm saying is that typically, a circuit breaker will trip, they'll reset it, and everything is back to normal. So there's no permanent problem on the circuit. So these are typically the symptoms of elevated harmonics. Well, harmonics are a form of electrical pollution, which results in the distortion of the electrical supply waveform, which can be destructive for a whole bunch of electrical equipment. The harmonics are typically generated by the electrical equipment installed in a business. There's cases where the harmonics are induced from other businesses in the environment, but typically the vast majority of the harmonics are generated by the business itself. And the harmonics are trying to travel away from the business towards the power source, ESCOM. And in that way, if a site is extremely polluting or has got very high harmonic levels, it will affect businesses in its vicinity. So as a result, elevated harmonics will result in the premature failure of electronic equipment, motors running hotter or experiencing vibration, excessive vibration, premature bearings, cannot be explained in any other way, for example, misalignment. The elevated harmonics can result in many different types of failures, and that's why it's important to monitor them. So elevated harmonics lead to higher peak-to-peak voltages, which can damage the installation of electrical equipment. They also result in a higher current load, so that results in high operating temperatures of motors and electrical cables, which can lead to premature failures. High currents also lead to nuisance tripping of circuit breakers, which are totally correctly rated for the load they are protecting, if there were no harmonics. So that's what we mean by nuisance tripping, is that the harmonic current superimposes it on the actual load current of the motor, and as such you raise the total amount of current traveling through a protection device, and that's why they can trip on for no apparent reason. Power factor and harmonics are two separate entities. Harmonics are a form of electrical pollution, and a poor power factor is caused by an inefficient usage of power drawn from the grid. So basically, where the installation is drawing excessive amounts of reactive power from the grid rather than getting it supplied from a power factor correction system. But there is a link between harmonics and power factor. So excessive harmonics will actually worsen the power factor of an installation. So it could be that the site will have an acceptable cos phi, which is the power factor that doesn't take in consideration the harmonic content of an electrical system, but an extremely poor power factor as a result of the harmonics that are being generated by the installation. So although they're two separate phenomena, the harmonics can worsen the power factor, overall power factor of an installation. Well, harmonics can be measured with specialized test equipment, and typically, you would have equipment that measures the voltage harmonics and the current harmonics at a specific site or at a specific problem area within the site. And the severity and type of harmonics measured are then compared to international standards, which have defined maximum permissible levels for each harmonics. So it's not like we're guessing. Once we have the data, we compare the data to what acceptable standards are. And once they're exceeded, we then know that an intervention is required. So with the right data and the right standards, it is possible to determine what is required at a specific site. So when we identify sites that have elevated harmonics, then there are a number of filtration systems which can be installed at strategic points. So typically, the assessment will initially start at the electrical supply coming from the utility. If we measure elevated harmonics at that specific point, we will then start our investigation and look for the sources of the harmonics within the plant. Again, it's with specialized equipment, but it's not an extremely complicated process. It typically can be concluded within a day on a specific site. The idea is to find the most cost-effective solution to bring the harmonic levels within an installation within an acceptable level. So typically, you would look at a combination of options. So on VSDs, you could install line reactors, and you could also install passive and active filters at trouble spots. So there is no need to look for perfection. Harmonic levels up to certain safe levels are completely acceptable. The trick is to find the least possible investment for the best result. Perfection by eliminating every single harmonic inside a business is actually extremely expensive and makes no financial sense to do it. So yeah, there are a number of possibilities, and you can never say up front what the solution is going to be. You need to carry a full analysis of what's happening at the site. Well, thanks for watching. If you found this helpful, please like and subscribe. There's a blog with more info linked in the description below.